Okay, good afternoon, evening, or morning, depending on when you're watching the video. We're on day 7 in the series and sequence, first unit in Pre-Cal 20. This is the last topic. We'll still be a few more days, like we'll do a review day and then a hand-in day or two. So there's still a couple more days in the unit, but this will be our last topic. Okay, today's video should be 35 minutes or so. And what we want to look at in day 7 is infinite geometric series, which is section 1.5 in our texts. And we're going to define what it is, an infinite geometric series. We're going to present the formula that it has, do some examples with the formula, and do some applications also with infinite geometric series. So the first thing is, if you were to think of a sum and you're saying to yourself, well, Mr. Englund, if a series goes on and on and on and on and on and on forever, how can it have a sum? Doesn't really make logical sense, but it can. And I'll show you how here. Let me show you what we're talking about. And there's certain conditions that you need to have a sum. So if you took a piece, a line, and if you were to cut that in half every time, you would have, and those would be your terms. So the first time you cut it in half, second time you cut it in half, and you could do that in forever, and it would still give you a total of the original piece that you had. So that's how an infinite geometric series works. It's really important that you have, I guess it's the ratio, pardon my stuttering there, the ratio being less than 1 and not negative as well, as we say. So let's define what an infinite geometric series is first. So if we say infinite geometric series, we mean an infinite geometric series. Okay, what do we mean by that? Has an unlimited number of terms. Okay, and basically it has a geometric, it goes on and on and on. Okay, so we use the symbol like this. I don't have it on the smartboard, so I'll have to use marker. So kind of like this sideways 8, that represents infinity. So we use this symbol, sum of an infinite series. This is what we use, an S with an infinity subscript. This is the sum of an infinite geometric series. Okay, so we're going to talk about the two kinds of series that are infinite. There's convergent ones or congruent ones and divergent ones. Okay, so we'll talk about what those are first by defining them and giving an example. And if we talk about a congruent infinite series, I gotta spell that right here. Okay, is a series that the partial sums approach a fixed value. Okay, and a divergent series infinite series. The partial sums do not approach the fixed value. They're opposites. And underneath that, the congruent test is simply the value of R has to be between -1 and +1. So it can be negative. I misspoke earlier. The value of R, which is a common ratio, is between -1 and 1. So it's a part, it's a fraction or a decimal. It's not bigger than 1, it's not 1 at all. So I'm going to give you an example of each of these, a congruent one and a non-congruent one, or a diverging one. So if I do a congruent example, and I'll use a marker for this. So let's go into here. So if we have a congruent one, okay, so let's say I start with 80 times by a half, 40 times by a half, 20 times by a half, 10, dot, 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 dot. So if I do the partial sums, okay, partial sums will be approaching basically 0 as we go. So this will be 120, then I'm going to 60, then I'm going to 30 and 15, and then if I do 5 and 2.5, and so forth. So it's going to approach 0. In this case. So that's congruent. A divergent one. Okay, so I'm going to do one that has a ratio that's above 1 or below -1. So let's say if I started with 2, then I multiplied by 2 to go 4, and then multiplied by 2 to go to 8, and then 2 to go to 16, and 32, etc., etc., etc. If I do the partial sums, this is 6, this is 12, this is 24, and so forth. So it's climbing, so it's approaching infinity. Okay, so this is divergent. It's not approaching 0. This one would be congruent because it's approaching a fixed value of 0. Eventually, when we get way, way down at the other end, it'll be close to 0. Okay, and that's the difference between them. So the one that we're dealing with, the infinite geometric series, is congruent. Okay, it's going to approach 0. So all you have to do to test it is know that R is between two numbers. So if I said, is the following series congruent? Okay, so let's say I had, I don't know, let's say I started out with 20, and then I went times by a half, and times by a half, 5, dot, 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 dot. So the test is find R. If R is a fraction in between them, so we go T2 divided by T1, so this would be 10 over 20, which equals 1/2. So yes, because R is in between -1 and +1. Okay. Okay, so let's define the formula that we're going to use, and we'll do a few examples using that formula, and then we're going to use the infinite geometric series to turn repeating decimals into fractions. Will be our last example, I think. Okay, so let's take a look at the formula. For infinite geometric series, now R has to be congruent. Okay, so an infinite geometric series has to be congruent. So that means R has to be between -1 and 1. So if you're doing that, it's just the sum of an infinite series that is congruent is equal to the first term divided by 1 minus R. And R cannot equal, okay, I guess R cannot equal 1, and R has to be between, because it's congruent, it actually has to be between -1 and 1. So it has to be a fraction. Put a comma in there. So let's take a look at an example. Find the sum given this series. We'll do a very simple example first. Find the sum of the following series. Okay, let's use fractions here, because why not? Okay, so I got an example here, but I'm going to use fractions, so I'm going to use my marker to write it down. So let's say that we have our first term is 1/2, and then 1/4, and then 1/8, and 1/16, and so forth. Dot, 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 dot. Okay, so we know that R has to be found first, because we know what T1 is. So R is just T2 divided by T1. So that's going to be 1/4 divided by 1/2. So if you take and do the fraction rules, which means you take the quarter and you multiply by the reciprocal, you're going to get 2/4, which is 1/2. So T1 is 1/2 as well, because it's the first term. So we get R and T1 both being halves. So let's plug in our numbers into the formula now. So the sum of this series will equal 1/2 divided by 1 minus 1/2. So that's going to equal 1/2 divided by 1/2, which equals 1. So the sum of that series is going to eventually come to 1. Okay, let's do another example. Let's say I had 200. Let's put a line here so we can divide example 2. And then we multiply by a certain amount and get 80. Multiply by that same amount and get 32. And multiply by the same amount and get something. We'll say those three will be enough. We keep going. So the first thing is to calculate R. R is going to be T2 divided by T1. So 80 over 200 equals, well, that's 8 over 20, or 4 over 10, okay, or 0.4 if you like, or 2 out of 5, depending if you want fractions. Let's do this one in decimals, because we did the last one with fractions. So 0.4, that's R. Okay, so T1 is 200. So when we do the sum of this series, it's going to equal 200 divided by 1 minus 0.4, which would be 200 divided by 0.6. Okay, so if we do that one, you get 333 and a third. Or if you round it to decimal, 333.33, we'll say. Okay, so there's a couple examples of just finding sums. Now that's not the only kind of example that you will see. Sometimes I'll give you an example where you have to find something else. Okay, so let's take a look at an example like that. Let me just check here and see how the time is on our recording here. Okay, so we are sitting at about almost 16 minutes, so we got lots of time here. Okay, so let's do the second part. Different kind of example. So using the formula to change repeated decimals into a fraction will be one of our last example, but let's do one solving for T1 given the sum in R, because we haven't done one like that yet. So let's say example type 2, finding T1 given R and the sum. So let's say that we have, well, let me see if I can dig it up here. I'm on the wrong, there it is. Okay, let's say that my sum is 92. And that my R value is 0.25 or 1/4. So, okay, you can use 1 over 4, or you can use 0.25 if you like. It doesn't matter to me. I like to use fractions because it gives me the exact results. So we know the formula is the sum is equal to T1 divided by 1 minus R. Okay, so if we want to get that, let's go ahead and put in 92 equals T1 is unknown and 1 minus 1/4. Okay, so if we work that out up here, 92 is equal to T1 divided by 3 over 4. Okay, so we've got to basically, to get rid of the 3 over 4, we have to multiply both sides here. If you like, if we want to get by 3 over 4. So we're going to multiply by 3 over 4 on both sides. So 92 times 3 over 4 is equal to T1. Because then if I multiply by 3 over 4, it cancels that out. So 92 times 3 divided by 4. And I get 69. So that is the first term of that particular equation. Okay. Okay, the last type of example I'm going to do is you can use an infinite series to take a repeated decimal and turn it into a fraction, because you can use the formula that we just used there to do that. So this will be our last type of an example here. So this is our example type 3. Okay, and this is converting a repeating decimal to a fraction. And that's the example that we're going to do here. So let's say that we have write 0. I don't know, 25 repeating as a fraction. Or no, let's not do that one. Let's get something that 0.63 repeating. as a fraction. Okay, so step one, we write this as a series. And this will be an infinite geometric series. Okay, so it's pretty easy to do. So all you do is you start off, okay, it's going to be 0.63 plus, now you just put the two zeros there. So 0.0063 for the next one, and then you just put two more zeros. 0, 0, well, how many ever digits are repeating, right? 0, 0, 6, 3, and then you keep on going. And that would be the sum of the series. So how are we going to get the sum of this? Well, we have to find r now. Step 2, find r. Okay, so r is equal to t2 divided by t1. So in our case, that's 0.0063 divided by 0.63. And this is going to give you 0.01 if you do it. So if you go 0.0063 divided by 0.63, you get that hundredth. Okay, so this is 0.01. Okay, and then in the final step, you just apply the formula for this infinite sum. Okay, so we'll make some space there. So step 3, apply the S infinity formula. Okay, so how do we do that? Well, you know that S infinity is equal to T1 divided by 1 minus R. So in my case, our case here, 0.63 is, and this would be 1 minus 0.01. So this is 0.63 over 0.99. And if we remove the decimals now, by multiplying by 100, that's 63 over 99, which we can reduce by dividing by 9. 9 into 63 is 7. 9 into 99 is 11. And that's our fraction. If we take our calculator and check it out, that'll give us decimal 63 repeating. And that is all the questions that will come in this type of area with infinite series. Okay, so we're sitting at, oh, look at that. We're only at 23. Let's do one more of these, and then we'll give you some practice. So what if I had, try this one. So you can pause once I write it down here and work it out, and then unpause and I'll work it out, and then we'll do the practice after that. Okay, so let's say, let me use, I don't know, let's go with find the fraction. Okay, and I'll just do 0.5 repeating. Okay, so that one there doesn't have 2, it just has 1. So you can do 0.5, 0.05, and so forth as you go. Okay, you can pause and try that, and I'll work it out. Okay, if you're unpausing, 0.5 plus 0.05 plus 0.005, and so forth and so on as we go along. So if we get R, that's going to be 0.05 divided by 0.5, which equals 0.1. Okay. And then we use the formula. Okay, so the formula S infinity is equal to T1, which is 0.5, over 1 minus 0.1. So this is going to be 0.5 over 0.9. And that would give us 5 over 9 if we remove the decimal. And that's pretty straightforward to do. So we're sitting around that 26-minute mark, so keep it at that under that 30 minutes. So practice for the rest of the period today. Okay, this is in section 1.5. Let me find my notes on that here. There we are. Okay, so this will be page 63 and so forth. And you can do like 1. Yeah, just do the ACEs, I guess. 2, ACE, 3, A and B, 6 and 7. Okay, and that takes us to the end of the series and sequence topics. Okay, there's a hand incoming, so that'll be posted up, and I'll give you a couple days to work on it. And when you get the hand in done, you just you take it. It'll be up there. It'll be open. You take it, print it out. If you can't print it out because you don't have Word, if you got a Chromebook or something, you might have to go to a Word computer, print it out or whatever. Or I might have to convert it to a PDF. We'll see. Okay, so you go and print it out. Do your work right on there. Scan it in and email it back to me, and I'll mark it and scan and correct it, and I'll scan it and send it back to you through your email. Also, if you don't know how to scan, it is okay for you to take pictures of them, of each sheet that question you do, and send that to me in email as long as the pictures aren't too big. But I really prefer if you can scan it. If you can take pictures, you can use CanScan on your camera. So that'll be next day. Okay, so we'll see you next day, day 8, and 9 will probably be work periods on that hand. All right, good luck. And before I let you go, and I also will do a quiz review in day 10. So I always do a quiz review. I go, what's on the quiz? What are the questions that you're going to be doing? We do an example of each, so there'll be a period of that, but that'll come after you guys do the hand-in. Okay, good luck.